Okay, so we have this question here that says we find the derivative of y with respect to x here. So before we start differentiating here, let's just get rid of the roots so that we have this written in terms of a power of a fraction or a number there. So now this here is just y equal to 5x to the power 4 plus 4x minus x to the power negative 3 divided by 2 here plus 1 divided by x to the power 2 over 3 like this here. So let's go right ahead and take this x up on top this side. So this is the same as y is equals to 5x to the power 4 plus 4x minus x to the power negative 3 divided by 2 plus x to the power negative 2 over 3 like this here. So now here we can differentiate this expression here because we've written all the terms here in a way that it becomes easy for us to differentiate x there. So dy dx here is going to simply be equal to the derivative with respect to x of all the functions that of all the terms that we have this set. So we have 5x to the power 4 plus 4x minus x to the power negative 3 over 2 plus x to the power negative 2 over 3 like this here. So we just scroll down a bit. So then differentiating these terms, power times coefficient, power minus 1, so 4 multiplied by 5, we're going to have a 20 x, then 4 minus 1, 3 there, plus 1 multiplied by 4, we're going to have a 4, then x to the power 0 is just 1 there, so minus again here, negative 3 multiplied by negative half here, we're simply going to get plus 3 over 2 x to the power negative 4 like this here. Then when we multiply here, the power that we have here is negative 2 over 3. We multiply by 1 here, we're going to have negative 2 over 3 x to the power negative 2. So here we're going to have negative 2 over 3 minus 1 like this. So 3 is our common denominator there. So 3 into 3, 1. So we're going to have negative 2 minus 3 here, which will give us negative 5 over 3 like this here. So meaning that here we're going to have negative 5 over 3. So now we've differentiated already, so let's just get rid of the negative exponents that we have here. So we know that if a variable has a negative exponent, then it's supposed to go in the denominator there. So meaning that here we have 20 x to the power 3 plus 4 plus 3 over 2 x to the power 4 minus 2 over 3 x to the power 5 over 3 like this here. So now this x to the power 5 over 3 here is the same as x to the power 5, and we have a power of 1 over 3 on top here. So we know that the power of 1 over 3 here just simply means that we're finding the cube root of that term. So here we're going to have the cube root of x to the power 5 like this. So we're going to go right ahead and substitute there. So meaning that here this is just simply going to be 20 x to the power 3 plus 4 plus 2 or plus 3 rather divided by 2 x to the power 4 minus 2 divided by 3, the cube root of x to the power 5 like this. So this becomes the solution to that problem here. Okay, let's look at the next one. Okay, so we have this question here that says if y is equals to that expression there, then we need to differentiate it and get the expression that is required this side. So now, first things first that we're going to do here is we're going to rationalize the denominator there. So we rationalize this function before we differentiate it. So here we have y is equal to the root of x squared plus 1 minus the root of x squared minus 1 like this here. Then we divide this by the root of x squared plus 1 plus the root of x squared minus 1 like this. So we rationalize the denominator there, we find its conjugate, then make a fraction of itself. So here, the conjugate is simply the root of x squared plus 1 minus the root of x squared minus 1 like this here. So then this here is going to be divided by, down here we have the root of x, the same thing, plus 1 minus the root of x squared minus 1 like this here. Okay, let me just scroll down a bit. So now we multiply the terms that we have on top here. So the root of x squared multiplied by the root of x squared plus 1 there. So I'm simply going to have x squared plus 1. Then minus, if we multiply negative times the positive, we're going to get a negative. Then the root of x squared plus 1 multiplied by the root of x squared minus 1. So that just gives us a difference of 2 squares there. So we're going to have x to the power 4 minus 1 like this here. So we multiply these two terms, we're simply going to have the same thing again, minus x to the power 4 minus 1 like this. Then when we multiply this by that there, so we're going to have plus, we have x squared minus 1 like this here. So then now here, all the terms that we have there, we divide them by the denominator there. So x squared, the root of x squared plus 1 multiplied by the root of x squared plus 1, we're simply going to have x squared plus 1. Then this multiplied by that term, we're going to have negative the root of x to the power 4 minus 1. Then when we multiply this plus this here, we're going to get plus the root of x to the power 4 minus 1, then minus x squared minus 1 like this here. So we'll go ahead and simplify that expression further. So here, these terms that we have under the roots are the same, so meaning that we can just add the coefficients here. So negative 1 minus negative 1 are going to get a negative 2, then 1 minus 1, so we have a positive 1 that's going to cancel with a negative 1 this side. So then we're simply going to be left with x squared plus x squared, we're going to get 2x squared. Then this here is going to be negative 2 the root of x to the power 4 minus 1 divided by, down here, this term and that term are going to cancel out, so we're going to be left with x squared plus 1 minus x squared plus 1 like this here. So this will give us 2x to the power 2 minus 2 the root of x to the power 4 minus 1 divided by 2 here, because this term and that term are going to cancel out here. So we can factor out the 2 that we have on top there. So if we factor out the 2 on top, we're going to have a 2 open brackets x squared minus the root of x to the power 4 minus 1 like this here. Everything is being divided by 2 like this. So 2 there is going to cancel out. So therefore now we have y here. So therefore y is simply equal to x squared minus the root of x to the power 4 minus 1 like this here. So now we'll go ahead and and differentiate throughout with respect to x here. So we say differentiating throughout with respect to x. So differentiating with respect to x there. So our dy dx simply going to be equal to, we differentiate this whole expression that we have with respect to x. So we have x squared minus the root of x to the power 4 plus 1 like this, or minus 1 like that. So then if we differentiate x squared, we're simply going to get a 2x then. Then minus, differentiating this term here with respect to x, we're going to change what we have here. So that will be x to the power 4 minus 1. Then we have the power half like this here. So now, the method of differentiation that can be used here is a chain rule. So we have a function inside another function, so we differentiate the function that is outside first, then we also differentiate the function inside. So now, if we differentiate this whole function the way it is, we're simply going to have 2x minus 1 over 2 here, like this. Then here we differentiate the function that we have, so this will be x to the power 4 minus 1. So half minus 1, we're going to get minus half like this. And then multiplied by differentiating the function that we have here inside, which is x to the power 4 minus 1. When you differentiate this function, we're simply going to get 4x to the power 3 like this here. So now, anything that has a negative exponent is supposed to be on the denominator there, so meaning that this term is simply going to be 2x minus 1 over 2x to the power 4 minus 1 to the power half, like this. Then we have our 4x to the power 3 like this here. So now, 2 there, 1, 2 there, 2 times. So this will just be equal to 2x minus 2x to the power 3 divided by, so n number raised to the power half is just simply, we're simply finding the root of that number there. So divided by the root of x to the power 4 minus 1 like this. So if we check from what is required there in the question, so let's just scroll up a bit and check our response there. Okay, so if you look at what we have here, it's exactly what we found there. So meaning that the first thing that we do with this question here, we first rationalize, then after rationalizing it, then the final expression that we get after rationalizing, that's the expression that we differentiate there. Okay, thank you.